Hello, Nawal, how are you?
Hello, sir. Fine.
So all of you just focus here. All of you just please focus here. We will discuss some of the good questions first, and after that we will start our topic. So this is a question of CBSE 2010, and in this question, first read the question. In this question, two identical slabs, two identical slabs of given material are joined together in two different ways as shown in figure A and B. So two figures are given and two slabs we have, and we are joining those two slabs in different ways. First way to join the slab is this, and other way is this. They are asking what is the ratio of the resistances of two combination. So first, just you should know how to solve this question. We have a slab. Slab means like this. Slab is something like this. You can see here, this is a slab. This is the slab. This type of slab we have. Two similar slab we have, identical slabs we have, see here, of given material. Material is same of both the slabs. Both the slabs. So this is slab 1, this is slab 2, and they have same length. Figure is given, but I am just drawing for the satisfaction. So length is same and material is same. They are saying of given material. Given material means they are saying the if the material is same, then the resistivity rho. If the resistivity of this is rho, then of this the resistivity will also rho, because the resistivity depends upon the material. Okay, and one thing more, area of cross section is also same. Area of cross section is also same. See this area of cross section. If the current is flowing in this way, and see here current is flowing like this, current will flow like this. So this cross section area means cross section area of both the slabs is same. And remember that what is rho? Rho is the resistivity. And resistivity is same because the material is same. Or this is written as identical. Identical means all things will be same. Area is same. Length is same. Okay. So if you want to find the resistance of this slab 1 R1, then we have a formula of resistance in terms of rho L divided by A, rho L divided by A. And if you want to find R2, then again you will have rho L divided by A. Means both the resistances R1 and R2 are same. So R1 equal to R2, I am supposing that R means the resistance of this slab and this slab is same. So now resistance we have calculated. Now in this figure, see this figure, here two resistances means two uh, slabs are joined like this, and this combination is a series combination. Series combination. So you can write from figure A, we can conclude that resistances are connected. Resistances means slabs are connected in series. Why they are connected in series? Because from here to here the current will be same. This combination is the series combination. So in series combination, if you want to find the total resistance or equivalent resistance, then you will write R1 plus R2, and R1 plus R2 both are same, that it will become 2R. So in this case, equivalent resistance is 2R in case of series. So this is equivalent resistance in series. Equivalent resistance in series is 2R. So this is equation first. Now from figure second, means from figure B, this combination is something different from this. This combination is the combination in which the potential difference will be same. In this combination, the potential difference will be same. And if the potential difference is same, then this combination is parallel combination. So you will write from figure B, you can conclude that resistances are connected in parallel. And if two resistances are connected in parallel, like this, if resistances are connected, one resistance is R and the resistance is R, connected like this, and this is connected like this. R, this is R. So equivalent resistance in parallel. What is the answer? I have told you first multiply both the resistances and do this. So you will get R square divided by 2R, and you will get the answer R by 2. So equivalent resistance in parallel is equal to R divided by 2. So this is equation 2. Or you can find the equivalent resistance in this case as 1 upon R equivalent in parallel is equal to 1 by R plus 1 by R. Then you will get, again you will get R by 2. But this takes less time, this takes more time. So depending upon you which equation you are using, both equations are same, but they are asking what is the ratio of the resistance in the two combination. See, just you have to find the ratio after this. equivalent resistance in series divided by equivalent resistance in parallel. What is the equivalent resistance in series? 2R. What is the equivalent resistance in parallel? R divided by 2. And R get cancel out. You will get this 4. So 4, I can write this 4 by 1. So ratio is 4:1. Okay. All of you just copy this. So in this way, you have to write the answer in your examination. Slab, here you will consider slab as a resistance. And A is for area of cross section, L is the length, rho is the resistivity, and this formula we have discussed. All of you, have you written this?
No, sir, no.
Yes, sir. Yes, sir.
Okay. Okay, Matthew, note it down. Just then we will discuss the next question.
No, sir.
Okay. Just complete this also. Now we have two more questions. One question you can easily solve, and another question is little bit confusing. Written, Matthew?
Yeah, sir.
Okay. Fine. Next question. So this question you can solve. Distinguish between the EMF and the terminal voltage of a cell. EMF is the maximum potential difference of a cell when cell is means when in open circuit, you can say. Okay, when cell is not in the working condition. And terminal voltage is the potential difference of a cell in the working condition, when means you can say in the closed, when the circuit is closed. We have discussed this question, so you guys can solve this question number 13. But I want to solve this question number, and this is asked 2013, and they are saying that, just read the question. They are saying that the EMF of a cell is always greater than the terminal voltage by. But I am not agree with this question. This is the incomplete question. They are saying the EMF of the cell is always greater than the terminal voltage. But this is not true. I will show you the terminal voltage can be greater than the EMF of the cell. We have discussed also. Suppose you have a cell having the internal resistance. Just focus here. This is very confusing question. I will say this is the incomplete question given by CBSE, and this is the EMF E of the cell, and this is the resistance R. Okay. So what I have told you, during discharging, discharging, so when the cell discharges, the direction of current is from positive terminal to negative terminal. So what we have written for the terminal potential or terminal voltage, V is equal to E minus IR. So what happens? Some of the voltage is wasted across this internal resistance of the cell. That is why the EMF of the cell is greater than its terminal voltage. So you can write sum of the potential is dropped across internal resistance. So that is why, see here, this, so you can say the EMF is greater than the terminal voltage. But I am telling you a case that in which the terminal voltage or will become greater than the suppose this cell is charging. This cell is in the charging condition, and in charging condition the flow of current is opposite, means the current flows from negative to positive, and what we have written E plus IR. So now from here you can say this time this terminal potential is greater than the EMF. Here terminal potential is greater than EMF during charging of cell. So this question should be asked like this. I will suggest ask like this. Will the EMF of cell is always greater than the terminal potential? If so, then give the reason. But terminal potential not always greater than the EMF not always greater than the terminal voltage. Okay, during discharging, EMF is greater than terminal voltage, but during the charging, terminal potential is greater than the EMF. So just note this down. But in examination, if this question will come, then what you will do? Matthew, what you will write?
The EMF of a cell is not always greater than the terminal
No,
voltage.
no, not at all. You cannot challenge CBSE because I want to tell you, because here they have assumed that they have already assumed that
In statements already there, we don't need to prove it
yeah,
false. I think.
in this statement there is a hidden statement. There is a hidden statement that I am writing here. They have assumed that cell is in discharging condition. Because what happens in real life also, what happens? Uh, uh, just take the example of your mobile phone. I am just giving you the feeling. Question has been solved. In examination, you will write from here to here. From here to here, you will get the full marks. And my work is finished. But I want to give you the feeling. Because in real life, what happens? The running time of your phone or the charging time of your phone, this time is greater. When you charge the phone, means suppose you are using your phone for 10 hours and you are charging your phone for 1 hour only. So generally what happens, the discharging time is more. So that is why you can say they have assumed that cell is in the discharging condition. Discharging condition. So for the discharging condition, this is true. But if someone is asking like that, if the question suppose in CBSE asked like that, EMF of cell is always greater than its terminal potential, or question mark, after that question mark, then you will say not always the EMF of the cell is greater than the terminal voltage, because in the charging condition the terminal voltage can be greater than the EMF of the cell. So just note it down. Now we will start our topic. So always remember the direction of the current during discharging. During discharging, current is flowing from positive terminal of a cell towards the negative terminal. But in charging, the condition will be opposite. And this V is the terminal voltage or terminal potential difference. When you will check your notes, you will get this equation and this equation also. Terminal voltage or terminal potential difference. Just note it down and we will start our topic. Now we have very easy topics. But in Kirchhoff's law, you will get some problem. You might get some problem due to the calculation part, but that is too easy. But in the combination of cell, when we combine the cell and when we calculate the equivalent EMF and equivalent resistance, that is very easy. So written all of you?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. This also,
No, sir.
but please write this also. You have to remember this. The examiner can ask you in 2023.
Yes, sir. Finish.
All of you finished?
Yes, sir.
Okay.
Yes, sir.
So okay. So now we have discussed this in the last class. Just I am reminding you what I have discussed in the last class. So in the last class, we have discussed the EMF. What is EMF and internal resistance, terminal potential difference, and after that we have seen the special cases of terminal potential difference or terminal voltage. Two cases were there. Sorry, four cases. And during charging, I have written this. And during discharging, I have written this. And during charging, I have marked the star also. So now we will solve one question. This is the question, and I want all of you first note this question down and understand the question first. Then I will solve this question. I am just reading the question for you. A battery of EMF capital E and internal resistance small r gives a current of 0.5 ampere with external resistor of 12 ohm and a current of 0.25 ampere with external resistor of 25 ohm. We have to calculate the internal resistance of battery and EMF of cell. Means we have to calculate small r and we have to calculate capital E of the cell. First note this question and read it once, then I will solve it. Completed all of you?
Yes, sir. Yes, sir.
Matthew?
Yes, sir.
Okay. Now they are saying a battery of EMF here internal resistance R gives a current of 0.5 ampere with an external resistance of 12 ohm. So what is the meaning of that? We have a battery. This is the battery we have. This is the internal resistance of the battery and this is connected with a 12 ohm resistance. EMF is the E and R is the internal resistance of the cell and current will flow like this. Okay, current will flow like this. So if you want to calculate this current, what you will do? I is equal to E divided by the total resistance. You will write what is the total resistance? 12 plus R. And the current is given as 0. 0.5 ampere. this current is 0.5 ampere is flowing in this condition. This is condition first. So this is 0.5. From here you can get this E 0.50 12 plus R. This is the equation 1. And now they are saying, after that they are saying for the condition 2, when you will read the question, you will get same cell or same battery is connected with a resistance of 25 ohm resistance, external resistance, and this time the current is 0.25 ampere. So just write the equation for the current. Current is EMF divided by the total resistance. What is the total resistance? 25 plus R. Total resistance is 25 plus R. From here you will get E 0.25 25 plus R. This is equation second. Now this is E and this is E. This E and E equal means this thing and this thing also equal. So you can equate equation 1 and equation 2. So what is equation 1? 0.50 12 plus R, and this equation 2 25 plus R, and this will get cancel out. Here it will come 2, and when you will multiply this you will get 24 plus 2R. Here you have 25 plus R. From here you can write 2R minus R. From here you will get 25 minus 24. You will get internal resistance as the 1 ohm. Now for calculating the EMF, you will put this R is equal to 1 in any of the equation. I am putting in equation 1. So equation 1 is 0.25 12 plus R. So 0.25 12 plus 1, instead of R place 1. So you will get the answer 0.25 into 13 6.5 volts. You will get the answer 0.65 volts. So this is the answer. I have just applied the formula of current. I have made 2 equations and solved that. To solve those 2 equations, I have got the answer. First answer is this internal resistance and EMF. So just copy the answer. What we are doing here in this question, we have a cell, we have a battery, and first we are connecting the battery with a 12 ohm resistance, and that gives the current of 0.5 ampere. So I have made one equation. After that, we have the same battery and we have connected it with 25 ohm, and we are getting a current of 0.25 ampere here, and we have got the second equation, and we have solved both the equations and got the answers. So one thing in mathematics is that if you have 2 variables to find, and if you have 2 equations, then you can solve easily. If you have 3 variables and you have to find if you have to find 3 variables and you have 3 equations, then you can find it easily. Those who are taking the screenshots, I want that arrange the screenshots in a proper manner. Otherwise, there will be no use of taking screenshots. Matthew, should I scroll?
Just a second, sir. Yes, sir.
Okay, fine.
Sir, the final answer R is equivalent to.
The final answer, there are two final answers. See here, in the first, this is the first part of the question,
Yes, sir.
R. So this is the first answer.
Yes, sir. I'm talking about this.
This
What
is the
is
final.
what is that? Is that 2 ohm?
No, this is 1 ohm. This is 1 ohm.
Yes, sir. Okay.
You can check the calculation if you are getting confused here. This is 2R minus R is 1R. 25 minus 24 equal to 1. And this is 6 point, sorry, you can check from here. This is 6.5 volts. 6.5 volts. So after this, we will connect these cells in series. We will study the series combination of cell. We have discussed the series combination of capacitors, series combination of resistors, series combination of cell. Now we will discuss. Completed all of you?
Yes, sir.
Matthew, Nawal?
Yes, sir.
So series combination of cells. Write the heading series combination of cell. So there are two types of series combination. There are two ways to connect the cells in series. So the first way is connect the cell like this. And I want to clear one thing. Cell is represented like this. This is cell, representation of cell. This is positive terminal of the cell. This is smaller line is the negative terminal of the cell. So I am connecting cell in series. So this is the representation of cell, and suppose if E is the EMF of the cell, R is the internal resistance. This E is the EMF of the cell, R is the internal resistance of the cell. So this is the representation of cell. So now we will take cells of different EMF and different internal resistance and connect them in series. So I am having a cell. So I am connecting like this. Now this cell have EMF E1, internal resistance R1, E2, R2, E3, R3. This is the external resistance R. Three cells I have connected, and this is the combination in which the positive, this is negative, means the negative terminal. I will explain it. Negative, this is positive, this is negative. So you can see here, negative terminal of one cell is connected to positive terminal. Negative terminal of one cell is connected to positive terminal. Negative terminal of one cell is connected to positive terminal. So this is a case where the negative terminal of cell connected to positive. So in this case, when you will find the equivalent resistance and when you will find the direction of current, the direction of current in all the cells will be same, like this, because we have connected the cells like this. If the direction of current is like this, in all the cells the direction of current is same. So if I want to find the equivalent EMF of all the cells, equivalent EMF. So equivalent EMF means E, this E. This is equivalent EMF, and this is equal to even, we will add all the EMFs. And equivalent internal resistance, we will add all the resistances. If we have n number of cells connected, then we will add EMF n time, add the internal resistance n time. Okay. So second case I am taking. I am having a cell like this, and this time I have connected this like this and like this. Means there is a random connection of cell. It is not necessary that the negative terminal of the cell here, in this case, negative terminal of the cell will be connected to the positive. So just see that how I have connected. This is positive, this is negative, this is negative, this is positive, this is positive, this is negative. So here both types of things presents here. Negative and negative terminal of both the cells connected, positive and positive cell of both the cells are connected, and one positive terminal of the cell is connected to the negative terminal of the cell. So suppose you have to choose the direction of current. Just choose the direction of current here. I am choosing the direction of current. Current is flowing like this. So this cell, in this cell, the current is leaving the positive terminal, means the direction of current here in this cell is from the positive terminal of the cell. Suppose this is E1, R1, E2, R2, E3, R3. E1 is the EMF of this cell, R1 is the internal resistance of this cell. So here you can see the current is from positive terminal to the negative terminal of this cell. So means this cell is discharging condition. And this is the cell. You can see here in this cell the current is flowing from negative terminal to the positive terminal. So this cell is charging. So here in this cell you can see the direction of current. The direction of current you can see is from again positive terminal to negative terminal. So this cell is also discharging. So the direction of current will tell you whether the cell is in the charging condition or in the discharging condition, and this is the external resistance. This is the external resistance. So how you will calculate the equivalent here, equivalent EMF? Either you can take the charging as positive, or you can take the discharging as positive. मतलब you can take the charging EMF as positive or the discharging EMF as positive. But I will suggest you take the bigger EMF as positive. So I am taking the discharging as the positive here. Positive, discharging, negative. This is positive. So this is just a sign convention. You will get the same answer again and again. So how I will write the equivalent E1 minus E2 plus E3. E1 minus E2 plus E3, and resistance, internal resistance will be always added, will always be added. Equivalent internal resistance will be added always. R1 plus R2 plus R3. This E suffix E is the equivalent EMF, and R suffix E is the equivalent internal resistance. Equivalent internal resistance. So in this case, if you want to draw the equivalent circuit, then you can draw like this. You will replace all this cell with a single cell of equivalent EMF and equivalent resistance. Here R is connected. This is E, and this is R, E. You can copy this here also. Means equivalent circuit of this. Instead of all these cells, you have connected a single cell. Any problem to anyone?
No, sir.
Means you
No,
have
sir.
to just uh, take, you can take any of the EMF as positive or negative, charging or discharging. We have taken here the charging as the positive, but when we will solve the question on this, then you will get the concept clearly. So just note it down, all of you. I am having a question on this. So here the negative of one cell is connected to positive, but here this is just the random connection of cell. Both the connections are possible here. Written this?
No, sir. Wait.
Okay, fine. And please draw the diagrams clearly. All the things should be mentioned there. So in future, when you will revise your notes, it will be easy for you. And what is the meaning of here? C and D? D for discharging, C for charging. So I am writing here, D is for discharging. And C is for charging.
Sir, please scroll.
Just add this point in your notes.
Done, sir.
Done. All of you completed?
Yes, sir.
Okay. So just write this question first. This is the question on charging and discharging. And this is the question of NCERT also. they are saying a storage battery of EMF 8 volt and internal resistance of 0.5 ohm is being charged by a 120 volt DC supply using a series resistor of 15.5 ohm. What is the terminal voltage of a battery during charging? And after that, they are asking, what is the purpose of having a series resistor in the charging circuit? So this question is like that you want to charge your mobile phone with the power bank. All of you written?
Yes, sir.
Yeah, sir.
Fine. So just see the question. Uh, so a storage battery of EMF 8 volt and internal resistance 0.5 ohm, 0.5 ohm means we have a storage battery like this. This is the battery we have, and this battery have the EMF of 8 volt and internal resistance of 0.5 ohm. This battery is being charged, they are saying. Being charged means the direction of current is from this terminal, means from this positive terminal. The current in the battery will be like this. The current in the battery will be like this. And this battery is charged by a 120 volt DC supply. So charge means you have connected this with some other battery. So this battery is charging, means this battery is charging. So you can suppose this is the battery of your mobile phone and this is a power bank. And when you charge your phone with a power bank, your battery is charging, your phone's battery is charging, but at the same time, the power, the battery of the power bank will discharging. Okay, means you have connected your phone with the power bank. Power bank also have the battery. So the battery of your phone, if the battery of your phone is charging, means the battery of the power bank is discharging.
Yes, sir.
So here this is, if this is charging, then this 120 volt battery is charging, this 120 volt battery is charging this 8 volt battery, but this 120 volt battery itself discharging, because this 120 volt battery is giving the energy to this, so this is discharging. So in discharging unit, and one thing more here, using a series resistor of 0.5 ohm, and here a series resistance is also used in this connection. A series resistance is also used. Here series resistance is also used, and the value of resistance is 15.5 ohm. This 15.5 ohm is in series with this battery and in series with this resistance also. So if this is discharging, then the direction of current is from negative to positive. So see, the direction of current is from negative to positive. So we have to find the terminal voltage. We have to find the terminal voltage of this 8-volt battery. They are asking what is the terminal voltage of the battery during charging. And during charging, I have told you, during charging, what is the terminal voltage? V is equal to EMF minus I into R. We have E, 8 volt. We have R, 0.5. But we do not have this I, and we will calculate this I from the circuit. Just calculate the current. What is the current? Current is equal to EMF divided by the total resistance. Equivalent resistance. So EMF, and how you will calculate the equivalent EMF? Current is equal to equivalent EMF. Equivalent EMF divided by the equivalent resistance. So how you will calculate this equivalent EMF? So you will take this EMF. This EMF is larger, so you will take this as positive. See here, positive and positive are connected. Okay. And for this 8 volt, you will take negative. So what is the equivalent EMF you have? 120 minus 8. And what is the equivalent resistance you have? You will add this resistance with this resistance because they are in series. So 15.5 plus 0.5 you will have. 15.5 plus 0.5. You will get this 112 divided by 16 and you will get the answer 7. So the current you have will 7 ampere current you will have. So now you can find the terminal voltage. 8 minus, you will put the value of current here. Instead of current you will write 7 and here is 0.5. So this will become 8 minus 3.5. So it will become 4.5. 4.5 volts. So the terminal potential difference of the charging unit is 4.5 volts. This is the answer. And half part of the question is remaining. So they are saying what is the purpose of having a series resistance in the charging circuit. So they have a series resistance of 15 ohm in the charging unit because this resistance will protect this cell from the higher current, from the large current you will say. So the purpose of series resistor you will write the purpose of series resistor is to protect the cell from large current. Large current. Just note this, all of you. I have taken here 120 volt as positive. See this statement. Consider cells having a greater magnitude as positive. So I have done this. So just note it down, all of you. And V, what is V? V is the terminal voltage or terminal potential difference. All of you just note it down, and when completed, please tell me. We will have a next topic after this.
So can you scroll down?
Okay.
Don't.
We'll have our next topic, parallel combination of cell, and this parallel combination of cell is not in your syllabus. Means parallel combination of cells is not in your syllabus. Parallel combination of identical cell is in your syllabus. So just note this down, and we will move. Okay. Now we have series combination of identical cells. Identical cell means a cell having equal EMF and equal internal resistance. Equal EMF and equal internal resistance. So I am taking cells of equal EMF and equal internal resistance. So I am just connecting the cell. This is one cell, and I am connecting n cells. I am connecting n cells in series of EMF E and internal resistance R, EMF E and internal resistance R, EMF E and internal resistance R, EMF E and internal resistance R. Number of cells connected in series is small n. Small n number of cells connected in series. So in this case, if you want to find E equivalent, then you will calculate, then you will just add all these EMFs in series. You will add all these EMFs. So you will write E plus E plus E. You will write this E plus E plus E n times. So if suppose if you are writing 1 plus 1 plus 1 3 times, then you will get 3 into 1 means 3. If you are writing this 1 4 times, then you will get 4 into 1, that is 4. If you are writing this 1 n times, then you will get n into 1. So in the same way, I am writing this E m n times, then I will get n times of E. And same is the answer for R equivalent. N times, you will add R equivalent, then you will get n times of small r. And this is the capital R resistance. And here current is flowing like this. So we can find the current. We can find the current now. If we want to find the current, then equivalent circuit we have to make. So the equivalent circuit means replace all the resistances with all these cells with a single cell of equivalent EMF and equivalent internal resistance. So this is EE and this is RE and this is R, and current is like this, I. So current is always equivalent EMF divided by the equivalent resistance, and equivalent resistance here R, this R plus this RE, this R plus RE. And what is E suffix E? This is NE divided by R plus N. So when you will take N common, if you will take N common, then you will get R by N plus here you will write N R. So you will get here R. Okay, and n will cancel out, and you will get the current I is equal to E divided by R by n plus R. So this is the current you will get in the series combination of identical cells. This is the current you will get. Now case 1, when the internal resistance of this circuit is much greater than this external resistance, means this small r is much greater than capital R, then I can write this R by N plus R is equal to R. So the current in this case will be E divided by R. Now case second, when the external resistance is much greater than R, then R by N plus R can be written as R divided by N. So the current will be I is equal to E divided by R by N. Then you will get the answer I is equal to N E divided by R. So this you will get. And in series combination for maximum current, so you will write here for maximum current, if you want in the circuit, we prefer series combination. If external resistance is large. So in the circuit, if you want the maximum current and if your external resistance is large, you should prefer the series combination of identical cells. So just copy this. Copy this, all of you. And if you have any doubt, if you want to ask anything, you can ask me. Here we have identical cells. Identical cells means having same EMF and same internal resistance. And I have already discussed what is capital E, what is small r, what is capital R. Capital E is the EMF of the cell, small r is the internal resistance of the cell, and capital R is the external resistance. Copy, Matthew, Nawal, and Nafisa.
Yes, sir.
Matthew, copied.
Yes, sir.
Okay. Just copy this.
So can you scroll down?
So you can see this current is maximum. This current is larger than this.
Done, sir.
Done. So one more topic and I will finish the class after that. So just remove here from here this mix. This will depend upon and are. But this statement has some meaning and we will get the answer of this statement when I will solve one question in the next class. So the parallel combination of identical cell and after that, so just write the heading parallel combination of identical cell. So I will take m cells, m number of cells connected in parallel. M number of cells connected in parallel. Just I will finish the topic in 10 minutes. So suppose the cell is connected like this, one cell is connected like this, another cell is connected like this. So we have n number of cells connected like this. We have connected n number of cells like this. Okay, and these all cells are connected with an external resistance R, and this is ER, EMF. Means here identical cells are connected in parallel, and if you want to find the E equivalent, we know that in the parallel combination E equivalent will be E, because the voltage or the EMF will be same in the parallel combination. For R equivalent, you will write 1 upon R equivalent is equal to 1 upon R plus 1 upon R plus, this is, you will write M times. So M times means you will add 1 upon R M times. So you will write here M by R. So R equivalent, you will get R divided by M. And if you want to find the current, then you will write E equivalent divided by R equivalent. E equivalent is E and R equivalent is R by M plus this capital R. So I is basically E divided by small r by M plus R. So this is the current. Now we will take case 1. When this capital R is much greater than smaller r, then you can write this as R, and you will have a current of E divided by R. Okay. Case 2, when you will have small r is much greater than R, then you can write R by M plus R equal to R by M. Then you will have a current of E divided by R by M, and the answer is E is equal to M E divided by R. So you will say that for maximum current, if internal resistance is large, then we prefer parallel combination. Parallel combination of identical cell. Just copy it, all of you. Okay. All of you just copy it. Now we will meet in the next class and we will discuss there the mixed combination of cell. And after that we will discuss the Kirchhoff's law. Mixed combination of the cell, and after that we will discuss the Kirchhoff's law. Just please note it down, all of you.
Yes, sir.
Matthew,
Yeah, sir. Done.
done na? Okay, just copy this also. and revise your notes before coming to class. This is r by m plus r can be approximately equal to r.
So can you scroll a bit up?
Okay, fine.
Yeah.
So all of you just revise your notes regularly and solve the questions as much as possible. If you are not getting anything, you can ask me in the class.
So you can scroll down.
Yeah. Nafiza, are you getting what I am teaching?
Yes, sir.
Okay, I suggest you to revise your notes as much as possible, and Matthew, you also, and revise the questions that
Okay, sir.
I have given you, I have solved in the class. And if
Okay,
you are
sir.
not, if you are not getting anything, if you have any problem in questions in theoretical part, and all of you, you can ask me in the class. Don't hesitate, you can ask me in the